We're now going to look at three-figure bearings in the context of sine rule and cosine rule questions. First thing we're going to do is identify when you should use the sine rule and the cosine rule. So sine rule and cosine rule are your non-right angled trig questions. So a good start to be thinking about is with the sine rule. If you're given two pairs of opposites and one unknown, so there's one pair of opposites and another pair of opposites with one unknown with a question mark, then you use the sine rule. So that would be sine rule for the side. A over sine A equals B over sine B equals C over sine C. Now let's say this time we had two pairs of opposites and one unknown again, but this time the unknown is the angle instead of the side. Well, it's still sine rule. A over sine A equals B over sine B equals C over sine C. So that's a good kind of recognition as to when to use the sine rule. If you've been given two sides and an angle sandwiched in between and you're looking for the opposite side, then that's cosine rule for the side. A squared equals B squared plus C squared minus 2bc cos A. Now you can be given that same information and the question might be area of a triangle, half AB sine C, but that's easy to identify because the question will say find the area of the triangle. If it's find the length of the opposite side, then two sides with an angle sandwiched in between. That's cosine rule for the side. A squared equals B squared plus C squared minus 2bc cos A. Another scenario is that you're given the three sides of the triangle and the unknown is one of the angles. And in that case you use cosine rule for an angle. Cos A equals B squared plus C squared minus A squared over 2bc. So that's our quick rules. Now we're going to start to look at some three-figure bearings. Now for bearings questions, two things that are really important to remember is that bearings are always measured from north. So they're always measured from north and they're always measured in a clockwise direction. Other things to look out for in bearings questions that can help us out is alternate angles are equal, that's Z angles, and corresponding angles are equal. And remember all your other facts about angles, like angles in a straight line being 180. Also, that if you're given two angles in a triangle, you can work out the third side quickly because you know that angles in a triangle add up to 180. And if you're given two angles in a triangle, I would always go forward and work that third angle out even if you think you don't need it. Okay, so let's try this question. In the diagram below, D, E and F, so I'll mark that as D, E and F, represent the positions of three towns, Dunbridge, Earlsford and Fairtown. Dunbridge is 15 kilometres west of Earlsford. Okay, so that's given in the diagram. From Dunbridge, the bearing of Fairtown is 126. So, from Dunbridge, the bearing of Fairtown, so that's to go in the direction of Fairtown, so from north in a clockwise direction, that was also given in the question, that's 126 degrees. From Earlsford, the bearing of Fairtown is 230 degrees, so it's always measure bearings from north in a clockwise direction. So this was given in the question as well. From Earlsford, north in a clockwise direction to get to Fairtown, and I've went in a clockwise direction there, and that was given to me in the question as well, that's 230 degrees. The question is calculate the distance between Dunbridge and Fairtown. So it's this bit in here that I'm looking for, and I'll call that small e, small d and small f. Okay, so we're now looking to find out information about angles inside the question. Now, having a close look, I can see that this angle here is 90 degrees and the full angle is 126, which means the smaller angle must be 126, take away that right angle, which was 90 degrees. That means the small angle inside the triangle there is 36 degrees. From north, if I go round a quarter turn, that's 90 degrees. Half turn, 180 degrees. Another 3/4 turn, that's a 270 degree turn. That's a 270 degree turn. and I know that that is a 230 turn. So 230 off of the 3/4 turn of 270 will give me 40 degrees in here, because 270 take away 230 is 40. Now at that point, you might think, well, I can calculate the size of this angle, should I? Well, I would just go ahead and do it anyway, because you might need it. So 40 plus 36 is 76. The angles in a triangle add up to 180. So 76 from 180, and that angle in there will be 104 degrees. I then have a look and see what rule could I use. So quite clearly then I can identify two pairs of opposites and one unknown, so I can use sine rule. A over sine A is equal to F over sine F. So A over sine A equals F over sine F. So small e is what I'm looking for, over sine A, which is sine 40, is equal to F, which is 15, over sine F, which is sine 104. I then cross multiply, and that will be E times sine 104 is equal to 15 times sine 40, 15 sine 40. I then bring the sine 104 down and divide. So A will be equal to 15 sine 40 divided by sine 104. And I input that into the calculator. And to one decimal place, that is 9.9 kilometres.